can do. I'll just show you one example. Okay, one or two examples, and then we go to the tutorial questions. Okay, so we consider the same schedule. For example, the schedule in previous example 4. So this is a schedule with two fixed ends. Okay, a beam has two fixed ends. Okay, we need to form 3 truss hinges. Okay. Here I provide you as a sign convention, but it is not useful. Okay, I will show you. Okay, it is not useful. You don't need to mind, but I will introduce the sign convention when we do the moment check. Okay, it's very easy. We assume the second moment is a positive moment and the following moment is a negative moment. That's all. Okay, that's all. Okay. So if you want to use a sign convention, please just need to understand. Second moment is a positive moment, and the following moment is a negative moment. Okay, but please, okay, do not use the sign convention at this stage. Okay, because we didn't do moment check here. So and then we introduce a diffraction configuration. So why we do not use factor 1/2 because. So diffraction can be any diffraction. We introduce any diffraction, okay, at the collapse, at the plastic collapse. Okay, so when 3 plus hinges is formed, okay, the diffraction configuration must be in this way. Okay, must be in this configuration. Okay, because we have a rotation here, we have a rotation here, we have a rotation here, and we can assume any diffraction because this is not true diffraction. This is not real diffraction, so we introduce any diffraction, and we have 3 parameters, 2 angles, and 1 diffraction, right? So, but only one is independent. You can select any one as independent. For example, here we select the rotation at the left end as an independent variable. So this is theta is independent, and then okay, so delta is equal to A times theta, right? A times theta. And also phi is equal to B times, okay, B times phi is equal to delta, so we can obtain phi in terms of theta. Okay, so please always, okay, represent, okay, other 2 parameters in one independent variable, independent parameter. You can select any one as an independent variable. Okay, so we can obtain the external energy. External energy is equal to the force times the diffraction here. The diffraction here is equal to A times, okay, theta here. Okay, so we can obtain the external energy. And how about the internal energy? Okay, we have a rotation at this plus hinge, so the rotation is equal to theta, and the moment is equal to mp here. Okay, so mp times theta. You don't need to mind the positive and negative. Okay, so this is the first one. This is a left plus hinge, so the internal energy is equal to mp times theta. And how about the rotation for the internal plus hinge? The total relative rotation is equal to the rotation for the left segment plus the rotation for the right segment. So rotation for the left segment is equal to theta, and the rotation for the right segment is equal to phi. So here is equal to theta plus phi. Okay, and for the right plus hinge, the rotation is equal to phi. So we can obtain the internal energy in terms of right rotation angle. So why I mentioned we can select any one as an independent variable, because this independent variable is always able to be eliminated from the 2 sides of the equation. So the final solution must be irrelevant to the assumed rotation angle or displacement. Okay, if you obtain the result about the correct force is a function as a rotation or diffraction, that means your solution is incorrect. Okay, so that's all. Okay, so we always able to, so this is a solution. Okay, so this is an energy method. Okay, this is a solution based on the energy method. Okay, based on energy method. Okay, and also, okay, let me introduce a second example. In the second example, again, okay, as I mentioned, okay, this is example 6 before, okay, and as I mentioned, there are 4 possible plus hinges, and in principle, you have to consider all different combinations, and each combination just involves 3 plus hinges. So here, I tried 2, okay, combination cases. Okay, so the first combination case is we assume the plus hinge at the left end, right end, as well as the first force application location. So we have a plus hinge here, and plus hinge here. And please understand that here is not, the second force application location is not a plus hinge. So here there is no rotation. This is just a rigid. Okay, just a rigid. Okay, so you assume, okay, if you assume here is a rotation theta, so we can obtain the deflection here, and also we can obtain the rotation phi. Please understand, also the second force application location is not a plus hinge, okay, but the force still has contribution to the energy, because even for the rigid rotation, we still have a deflection here. Okay, so we have a deflection here because some students ignore this term in the previous examination. Okay, so we have 2 terms in the external energy. Okay, and this is the internal energy for the left plus hinge, for the internal plus hinge, and for the right plus hinge. So from this case, we can obtain the load factor. So this is a load factor corresponding to the first case. We assume plus hinge, okay, at here, here, and here. And then we go to case 2. In case 2, we assume plus hinge here, and the second force application location, and the right side. So again, we can obtain the internal energy. This is external energy as well as internal energy. Okay, internal energy. So we have 3. We have 2 terms about the external energy, and also we have, okay, the internal energy. Internal energy from 3 plus hinges. Okay, for the first plus hinge, the rotation is equal to phi. For the second rotation, the rotation is equal to phi. For the second plus hinge, the rotation is equal to phi plus theta. Okay, and for the right plus hinge, the rotation is equal to theta. So total is 2 phi plus 2 theta. So we can obtain the load factor. And then you just need to compare. Okay, you find, okay, the load factor from the second case is less than the load factor from the first case. So the second case is a true collapse mechanism. That means the structure will collapse in the second mechanism. Okay, in the second mechanism. So this is a solution. Okay, this is a solution. Okay. So that's all. Okay, we take a 5 minutes break, and then I will show you the solution for the tutorial question. Okay.